Okay, so today we're going to do review day 2. This page is not in your notes, and so if you're a distance learner, there should be a PDF that we've added to the printable resources that has this lesson there, so you might want to go and print that out first just so you have it. Students that are at school or hybrid, we're going to print that out and get a copy to you. Okay, so you should have it, should just be a white piece of paper. All right, so the first one says, Mr. Johnson and Mr. Henderson are getting ready to play 2 rounds of chess. History has shown that Mr. Johnson wins 59% of the first games. However, Mr. Johnson tends to wear down faster than Mr. Henderson, and history has shown that he only wins 48% of the second games. Create a tree diagram that models what could happen in their next 2 games. Also, create a probability model for all the possible outcomes. Okay, so first thing you need to know is what are they actually asking me to do in this problem. First thing they want us to do is create a tree diagram of what could happen in the next 2 games for Mr. Johnson and Mr. Henderson. So they're going to play chess. And so basically it's who could win. And so we could have Mr. Johnson win, or we could have Mr. Henderson win. Well, in the first game, Mr. Johnson usually wins 59% of the time, which means Mr. Henderson wins 41% of the time. The second game, though, we could have Johnson or Henderson, Johnson or Henderson, okay? The second game, though, Mr. Johnson wears out faster, and he only wins 48% of those. So 0.48 for Mr. Johnson, which means Mr. Henderson wins 52%. Remember, these two always have to add up to 100. So 0.48, 0.52. And so this is a Johnson and Johnson win. This is a Johnson and a Henderson win. This is a Henderson and a Johnson win. And this one down in here is Mr. Henderson winning twice. Okay? And so now remember, we need to take and multiply these together. So go ahead and grab your calculator. We need to figure out what 0.59 times 0.48 is, and then round it to the 10th of a percent. And so I believe we are going to get 28.3%. The next one, Mr. Johnson wins the first one, Mr. Henderson wins the second one. That scenario has a 30.7% chance, and that's the same thing. I'm just multiplying 0.52 times 0.59. Third one, Mr. Henderson wins the first one and Mr. Johnson wins the second one, so 0.41 times 0.48. There's a 19.7% chance that that scenario plays out. And then Mr. Henderson and Mr. Henderson, there is a 21.3% chance. Okay? All right, then it says create a probability model. So remember, probability model is just this little chart down here that puts all the percents in it. And so we want a probability model for all the possible outcomes. All right, so I'm just going to use the word outcome here. And then we want the probability of whatever that outcome is. Okay? Well, the scenarios are Mr. Johnson could win both. Mr. Henderson could win both. Or if they do one of each, it's really a tie. Okay? Well, Johnson winning both, if we look at our tree diagram, that's the top one, so 28.3%. Mr. Henderson winning both is 21.3%. And then one of each, we need to add those two together, so 4950.4. And now remember a quick way that you can kind of check yourself. If I add these all together, they should make 100%, and I think they do if we added those all up, okay? All right, next one. What is the probability that Mr. Henderson wins the first game and Mr. Johnson wins the second game? All right, Mr. Henderson winning the first, Johnson winning the second, 19.7%. Okay, and what's the probability that Mr. Henderson wins both? So Henderson, 21.3%. Okay, all right, next problem. A committee of 4 people will be selected from a group of 8 men and 3 women. What is the probability that the committee will have exactly 2 men? All right, so it's been a while since we've done this. And so we want exactly 2 men. So there's a few things we need to figure out. We need to figure out how many different ways can I select a committee that has exactly 2 men, and how many total committees can I make. Okay, so I'm going to do the total first. I want 4 people. If I add these 2 together over here, I have 11 people. So there are 11 people available. I want to choose 4 of them. Okay, that should, once you realize what you got to do there, that should be the easy number to figure out. But a lot of times we forget how to get that total. Top, we want 2 men. There are 8 men available, so 8, choose 2. But now you have to ask yourself, anytime we do these committee problems or group problems, is your committee full? And in this case, it's not. It only has 2 people, but we want 4 people on it. So that means the other 2 people have to be 2 women. Okay? Now, go ahead and type these in to your calculator and then put your answers on that next fraction there if you haven't done this already. All right, we should get 84 out of 330. And then if I go figure out the percent and round it the correct way, I believe we are going to get 25.5%. Okay. All right, next one. What is the probability that committee will have at least 2 men? So we could have 2 men, or 3 men, or 4 men. Okay. 2 men, we've already done. That's the problem we just did. 840 out of 330. Remember, or means we're going to add. Now we want 3 men. So 8, choose 3 times, and then that means we need 1 woman. So 3, choose 1. Now the bottom, I know, is always going to be that 330 from now on. I don't need to keep recalculating that or keep rewriting the combination problem for it. Same over here, I know this is going to be 330. I want 4 men, 8, choose 4, and then I don't need any women, okay? So this turns into 84 over 330 plus this one. If we go type this in, so 8, choose 3 times 3, choose 1, I believe we're going to get 168. Make sure you double check and make sure that you are capable of getting 168. Plus 8, choose 4, I think is going to be 70. If I add these all together, 322 out of 330. I divide that, and there's a 97.6% chance that we are going to get 2 men or more. Now that seems really, really high, but you need to remember this initial scenario. There's only 3 women to choose from out of the 11 people. It's going to be hard to get them, if we're just randomly selecting, it's going to be hard to get a woman onto the committee. Okay? All right. Or get a committee that's got all 3 women on there, I should say. All right, next page. It says a certain airline flight from Los Angeles to New York is late 30% of the time. When the flight is late, 20% of all passengers have lost luggage. When the flight is on time, only 10% of all passengers have lost their luggage. Draw a tree diagram to illustrate the status of a person's luggage if they take this flight. All right. So the first thing that we got to figure out is what's the probability that I'm on time? Okay, so I'm on time, and then I'm going to use that notation for the complement. So T stands for on time, T with the complement means we're not on time, okay? So a certain airline flight from Los Angeles to New York is late 30% of the time. That means we're not on time. So 0.3 actually goes down there. That means we are on time 70% of the time, okay? Now, that takes care of whether I'm gonna be on time or not. Now there's the issue with our luggage. I keep my luggage or I lose my luggage. I keep my luggage or I lose my luggage. Now, sometimes on a problem like this, it wouldn't be a bad idea to say what everything stands for. Okay, so T stands for time, TC stands for I'm late, L stands for I have my luggage, LC means I lost my luggage. Okay, all right, so when the flight is late, so that's down on the bottom down here, 20% of the passengers have lost their luggage. So 0.2 goes down there, which means 80% goes here. Remember, they have to add up to 100%. When the flight is on time, only 10% have lost their luggage. That means 90% still have their luggage, okay? All right, so now, so I'm on time with my luggage. I'm on time, but I lost my luggage. I'm late, but I have my luggage. I'm late and I lost my luggage. Okay, so that's what those all would stand for. So now these are pretty easy. I don't even really need to do a calculator. So remember, 0.7 times 0.9 is the same as 7 times 9. And gives me 0.63, which is 63%. 0.7 times 0.1 would be 0.07, which remember means 7%, not 70, but 7. 0.3 times 0.8 gives me 0.24, which is 24%. And down at the bottom, 0.3 times 0.2 is going to give me 0.06, which is 6%. And then remember, a good check, if I add these all up, they should make 100%. Okay, if we've done it correctly, it should make 100% when we're done. Now it says build a probability model and show all the outcomes. So on the last one, we could kind of group some things together. This one, we can't really group things together because they're kind of all different. So I have outcome and then the probability of that outcome, okay? So I'm gonna use the notation since I did it. So on time with my luggage, on time I lost my luggage, late with my luggage, late, no luggage. Now I can get away with doing these abbreviations because I gave a key up above. If I don't give a key, I have to put the words here. I'd have to say on time luggage. I'd have to write it all out. So 63%, 7%, 24%, and 6%. Okay, so this one was fairly easy once we got it set up. What is the probability that a passenger's luggage did not get lost on the flight? So they kept their luggage. I keep my luggage here. I keep my luggage here. So 63 plus 24. I have an 87% chance of keeping my luggage. Okay. All right, let's go to the next one. Use the results of the survey below to find each probability. And then the question was, to some people, how many siblings do you have? All right, so this one's one of those two-way tables that we've been working on the last few lessons. So what I would like you to do, if you haven't done this already, I want you to pause and do the entire problem and the 3 questions down below. So do everything we need to do for this problem. Okay, so first thing I should do is add everything together that I can if they haven't already added it for me. Make sure you're just watching. Remember, we've had that in our homework. Sometimes they already add it for us. So this one I should get 15. Here I'm going to get 23. Here I'm going to get 11. Here I'm going to get 6. Okay. Then if I go across, I believe I'm going to get 22 guys. If I go here, let's see, 29, 33. And so 22 and 33 should give me 55. And then remember, you want to check both ways. So 15 and 23 would be 38. This makes 49, plus 6 is 55. So I feel pretty good that we've added everything together. All right, so if we take these people and put all their names in the hat of the people that we surveyed, what is the probability that we get a female? There are 33 females out of 55, okay? Now, be careful. This is not 55%. This is not 33%. There's no percent sign on it. So they're not even showing me any percents. They're just showing me the decimal. All right, so 33 and 55 reduces to 3/5, which I believe is 0.6. So C is the answer we should have gotten, okay? Number 2, what is the probability that the person I pick has 2 siblings and is female? All right, so I got to look out of the females, and who has 2? 6 girls have 2 siblings. So there are 6 total people available out of the whole group. If I take 6 divided by 55, I believe 11% is the closest answer. Okay. Then number 3, probability of 2 siblings given female. So we know they're a female. So that means it's out of 33 people because that's how many females responded. And then there are 6 of the 33 that have 2 siblings. So if I take 6 divided by 33, I believe I get 18%. Okay? All right, so today you should have the Review 2 assignment. Okay, whoop, that's tomorrow's. Okay, so today you should have the Review 2 assignment. It should be on Schoology waiting for you.